All right, now we're going to look at prime factorization, writing any number as a product of primes, but this time we're using a factor tree method. All right, how a factor tree works is you can use any pair of numbers that multiply to the original. So, for example, if I wanted to do the prime factorization of 18, which I did in my previous video using a factor ladder, okay, how it works is that you basically do these are branches of the tree. I also wrote in my notes that it's an upside down V. Yes. Okay. So choose any two numbers that multiply to 18 other than 1 and 18. So I could use 2 and 9 or 3 and 6, whichever ones you want to do. So let's say you thought 2 and 9. Okay. What you want to do is if the number is prime, and 2 is a prime number, I circle it. If the number is not prime, and that of course is called composite, but if this number is not prime, then I want to break it down. So what two numbers multiply to 9? And those two numbers are 3 and 3. If these are prime, you circle. Sorry for the glare. Okay. And once all the ends are circled, you are done. So 18 is 2 times 3 times 3, or 2 times 3 squared. Now, the cool thing about a factor tree is that you would get the same answer even if I didn't use 2 and 9. So if I used instead 3 and 6, 3 is circled because it's prime, but 6 is not prime. It is 2 times 3. I'm still getting 2 3s and a 2. They're just in a different order. But if I wrote them from smallest to biggest, I'd get a 2 and 2 3s, which is a 2 and 2 3s. Okay. This is the unique factorization theorem, also known as the fundamental theorem of algebra, that once you find a prime factorization of a number, it is unique. So 18 is always, forever and ever, 2 times 3 squared. It's never going to change. That's its factorization. Okay. Now, we can use this method even for gigantic numbers. So, in a previous video, I did 405 with a factor ladder. Guess what? You can do that here as well. Let's say you wanted to do 405, and you notice that it's divisible by 5. So, you use your calculator, and you go 405 divided by 5 is 81. So, 5 times 81 is going to get me to 405. So 5 is prime. If we look at our sieve, we will see that 81 is not prime. Okay? 81 is 9 times 9. Okay. 9 is also not prime. It is 3 times 3. And this 9 is also 3 times 3. So once all of my ends of my branches are circled, that is my unique factorization. So I have 4 3s along with a 5. So 405 is 4 3s along with a 5. All right, you do need to make sure you know both the factor tree method and the factor ladder method. I will ask for both on our last exam, okay? So this is our factor tree method with 2 separate examples.